Hello, everyone. My name is Sabina, and I'm welcoming you in the name of our entire Sentinel Hub team for today's Ask the Sentinel Hub team session. Actually, this one is the first session of this kind, so we hope you will find it useful. Prior to this event, we already shared with you an informative video which was prepared by one of our team members, Marco. And in that short course, he explains the fundamentals of remote sensing with a nice overview of common use cases and tools. Well, it's great if you already watched it, but no worries if you haven't. You can still find it among our previous webinars on our YouTube channel, which you can see now on the screen. This is also a good starting point for all of you who are just entering to the field of remote sensing, as well as those who would just like to deepen your understanding. As you probably already know, we try to share our knowledge through different channels. We recommend you to visit also our education page with tutorials, guides, and plenty of useful links. On this slide are stated just a few. You can see our documentation, custom scripts repository at GitHub, our available data collections, and of course, we will share some more during this session. Now we will first answer the questions which we received in advance. My colleague Monia already prepared the answers. So that's all from my side for now, and I'm giving the word to Monia.
Hi, everyone. So as Sabina mentioned, we will first answer the 18 questions that were already delivered to us in Slido beforehand. We have categorized them into three main categories. The first one will be about satellite data availability. The second category is about remote sensing questions. And the last one about Sentinel Hub API. Then when we are done with these 18 questions, we will have a live Q&A session. So let's jump right into data availability. The first question is, what is the highest available resolution for commercial data? In Sentinel Hub, both Airbus Pleiades and Maxar Worldview share this trait because both of them have a band that go as high as 50 centimeters in resolution. The second question is, which free satellite has the best resolution? So in Sentinel Hub, this goes to Sentinel-2 and Sentinel-1, which both have bands that are in 10-meter resolution. And the second place goes to Landsat 8 and 7 with 15 meters. Here on the right, you can see the area of Venice on the top image with Sentinel-2 in 20-meter resolution, and on the bottom one with Pleiades with only half a meter resolution. Maybe as an interesting note, there is also one of the highest resolution commercial satellites currently in existence, goes to 30 centimeters, and that is Digital Globe. I will now quickly jump to our data documentation, where you can check for any satellites that you're interested in. For example, Sentinel-2, you can go to available bands and data, and then check the resolution for each of the available bands. Back to the presentation. Question number 3, why is there no images over some ocean areas? As you can see on this image on the right, areas over ocean do not have imagery for certain satellites, for example, Sentinel-2. This is deliberate because satellites that are genuinely meant for land monitoring do not take images very far away from land. This is because these satellites are generally of a bit higher resolution, and if they would be taking images over ocean, as you might imagine, most of the Earth is covered by ocean, so this would result in a lot of tiles that are not that useful and a lot of storage space that would be needed. However, there are satellites which are also intended for ocean monitoring, such as, for example, Sentinel-3, which, of course, also take images over ocean. As you can see on this image on the left, this is the Hurricane Douglas, which was taken over the middle of the ocean with Sentinel-3. Question number 4. Do satellites record all the time? Well, the sun-synchronous satellites, such as, for example, Sentinel-2, actually constantly take images. They circle the globe under the angle, and they return to the same area periodically in about a couple of days or something. And eventually, they cover the whole globe. So Sentinel-2, for example, has a revisit time of about 16 days. On the other hand, the geostationary satellites, such as, for example, weather satellites, image the same area all the time, and they usually have much lower resolution, but the frequency of data is much higher. So the weather satellite can take an image for example, every 13 minutes. Then we have commercial satellites, and some commercial satellites, such as, for example, Pleiades, only take images when tasked to do so, so not at all the time. Also interesting to note, optical satellites, which need visible light to produce images, image only during the day. However, radar and thermal satellites can image also during the night. Question number 5. Are there plans to add Sentinel-1 SLC data to Sentinel Hub? So the single look complex data currently is not planned because it simply takes too much space to be seamlessly integrated with Sentinel Hub. Question number 6, which corrections are available for Sentinel-1? So in this case, I'm assuming that with corrections, you mean the processing chain. And the processing chain goes like this. So first, we choose the original or multi-looked source, and then we calibrate to the chosen backscatter coefficient, and we also apply thermal noise removal. Then you have 3 options, which you can apply yourself if you want to. You can apply Lee speckle filtering to your images, you can apply radiometric terrain correction, or ortho rectification. Jumping to documentation quickly, if you go to Sentinel-1 GRD and find the processing chain from the menu on the right, you will be able to see the same processing chain, but also with useful links and the notes that might be of use. Okay, so now we are with in the remote sensing category with the question number 7. Which indices can I use for vegetation monitoring aside from NDVI? So NDVI is the most common index for vegetation monitoring, but there are a lot of other options that you can use. Our custom script repository, as Sabina already mentioned, has a list of, is full of useful algorithms and scripts. It includes vegetation indices and also other types of remote sensing indices. It also includes multitemporal algorithms, for example, max NDVI or average NDVI, algorithms for deforestation monitoring and bare soil detection, and also moisture indices and algorithm like NDMI or the stress index, which are also very useful because the moisture can also tell you about the drought and the stress of the vegetation and all that. Here on the right, I have collected a couple of useful vegetation indices that we have. For example, you have the soil adjusted vegetation index, or you have the EVI, the enhanced vegetation index, leaf area index, and so forth. If you're interested in this, I would also invite you to check the vegetation and agriculture teams in your browser. I will jump there quickly now. So if you go to Discover tab, you can select the team vegetation and forestry or agriculture, and here you will find a lot of these indices that I mentioned, and also composites that are useful for vegetation monitoring listed. You can click on any one of them and you will see the visualization, also a legend, a description, and so on. On our custom script repository, which you can find the custom script sentinelhub.com, you can find the indices and scripts for any collection. For example, for Sentinel-2, you can see them listed here. So you can explore this whenever you have the time. Question number 8, which bands and indices are most often used? So the most often used are actually the red, green, and the blue bands, which together comprise the true color composite. Then we have the near infrared band, which is heavily reflected by vegetation, and also it absorbs water. So it is used in most vegetation indices, and also it is used for water mapping. Shortwave infrared bands, for Sentinel-2, this would be band 11 and 12, and near infrared would be band 8. So these are known that the heat reflects a shortwave infrared band, so they can be used in wildfires, for example. They also absorb water, so they are often used in moisture mapping and also in bare soil mapping, as soil surfaces are reflected by them. Another very useful composite is comprised of near infrared red and green bands, and this is a false color composite which is showing vegetation in red. Then the 3 most often used indices are NDVI, the normalized difference moisture index, and the wetness index. You can see them only in your browser. If you only search for Sentinel-2 imagery, you will see all the most commonly used visualizations listed, just as we shown before, so you can explore them here. Okay, question number 9. How can I monitor changes in vegetation with Sentinel Hub? So this can be done in three main ways. You can use multi-temporal scripts, where you can, for example, check the average or maximum NDVI over a certain period. For example, on this colorful image down below, you can see the average NDVI calculated for each of the 3 months, and then each result is in the separate color channel, so red, green, and blue, and then as the colors mix, you get some kind of information how vegetation, how NDVI actually changed through time. The second option is to use statistical analysis. You can use it in your browser. You can just draw a polygon or for a point and then check the statistics for a certain period for any index. Or you can also use a more complex statistical API, which will allow you to do aggregations and exclude pixels and really cool things. You can also monitor changes using time lapses in your browser. As you can see behind this moving picture, shows how the vegetation, the NDVI has been changing through time. To learn how to do all this, check the EO browser and the multi-temporal scripting webinars. As Sabina already mentioned, we have a list of webinars available. So if you go to our website, let me show you where to find them very quickly. You just scroll down, click on webinars, and you can find them all here with the recordings. Question number 10. What is NDVI and what does the equation mean? So NDVI is a normalized difference vegetation index. It is a very common index used for monitoring vegetation, so the coverage of vegetation, density, and health. It is usually, it has values between -1 and 1, and it is usually visualized in green colors. It is comprised of the near infrared and the red bands. So the near infrared band is reflected by vegetation heavily, even more so than the green band, which we can see with our own eyes. And the red band, on the other hand, is absorbed by vegetation. So this means if we check the near infrared band in grayscale on the top right, this is band 8 in Sentinel-2, you can use the true color image to reference where the vegetation is. So you can see this is the forest. Then we have some vegetation also in these fields. And you can see that all of these areas are reflected quite a lot. How do we know this? Well, because the higher the reflection, the higher the pixel value and the lighter the pixel will be. So the lighter colors mean a higher reflection. The red band, on the other hand, which for Sentinel-2, this is band 4, we can see the contrary. We can see that the vegetation is being absorbed, and thus where we know the vegetation is, the values are very dark. So what the NDVI does is it combines this indicator of vegetation, the near infrared band, with the contra indicator of vegetation, which is the red band. If we just set near infrared divided by red, this would just be a vegetation index. But because we are actually dividing the subtraction by the addition, this is then a normalized difference vegetation index. So what is happening is the higher the value of the near infrared band, the higher the value of the NDVI, and the higher the value of the red band, the lower the value of the NDVI. So if we go quickly to your browser, we can see how this looks like. This is just colors applied to the grayscale visualization. You can see the legend here on the left, some more descriptions and resources for NDVI. Question number 11. I always downloaded an image on the area where I live, Sentinel-2. I would like to extract more information of it, for example, composition of water in a river. So again, I would advise you to explore the custom script repository, which has so many scripts, and you might even find some interesting ideas that you would like to explore for your area. Also, if you want to learn, if you're not familiar how to actually use these scripts and download imagery, you can see your browser webinar and also our scripting webinar. So specifically for water composition, we have several interesting scripts which detect chlorophyll and sediment content in water, which are indicators usually of poor water quality. As you can see on these 3 images, these are 3 different scripts which can tell you something about the state of the water bodies. If we jump to the custom script repository, for example, if I just Google marine, I will find the water-related indices visualizations for Sentinel-1 and also for Sentinel-2. You can explore them and check what works best for you. Question number 12. Is it possible to detect the removal of buildings with a combination of Sentinel-1 and Sentinel-2 data? So yes, this is possible in theory, but quite complex machine learning methods are needed. It is also very important that there are good quality reference data, and usually some kind of very high resolution data is needed, like orthophoto data or vector cadastre data or something like that. There can also be a problem with Sentinel-1 and 2 because, as we said, the resolution goes only as far as 10 meters. Some buildings can be smaller than that, and that can present an issue. However, if you have a very large built-up area, such as, for example, an airport, you can monitor it very quickly, even in EO browser, without any machine learning. The next question is very similar to this one, just for another topic. So how to classify crops with Sentinel-2? This is a bit easier to do, but still machine learning methods are generally needed, which means that you need good quality reference data. This is because the Sentinel-2 is not a hyperspectral satellite, only has so many bands, and it is just simply not that easy to figure out the type of crop just from looking at the imagery. You also need good quality reference data and machine learning. Also here, the resolution can be a limitation for very small parcels. Okay, now we will jump to our medium blocks. This block, land cover monitoring system, very briefly but still mentions the detection of buildings. And then the area monitoring crop type marker deals specifically with detection, with classification of crops. If you go to our Sentinel Hub medium, you will find a lot of interesting blocks, also the two just mentioned. And here you have also categories, machine learning, area monitoring, custom scripts, where you can learn much more about the topics. Question number 14. I don't understand custom scripts. What's the benefit of using them instead of analyzing in QGIS, and how can I learn more about them? So with using Sentinel Hub, custom scripts in Sentinel Hub, you get on-the-fly processing. You get almost instant visualization results. And you can use powerful JavaScript code that also supports data fusion and multi-temporal scripting. But one of the best things is that you also have the custom script repository, where you can just pull the scripts and visualizations that other people made and just use them anytime. So I will show you how easy this is. First of all, if you go to when you are on our website, if you go to develop and custom scripts, here you will find everything you need to know. We wrote the beginner scripting tutorial. You even have a short YouTube video and everything that is completely for people without any coding knowledge. Also, there's a beginner scripting webinar and a more complex webinar, so I would suggest you to start here if you're not familiar with script. And of course, you also have the advanced script documentation that you can dive deep. So if you are interested in custom scripts, don't worry, because we put a lot of effort into making them friendly and easily understandable to anyone. Over here, I have the wildfire in Russia, and I would just like to show you how easy it is to work with scripts in EO browser. If we just go to a custom script repository and we search for disaster algorithms with Sentinel-2, and then we check the wildfire visualization by Pierre Marcus, we can just drag it. And as you can see here, we can't see anything through the smoke. So this script is going to help us visualize it much better, because you see that Pierre Marcus made it so that heated areas are visualized very nicely with the shortwave infrared bands. You could now easily modify this script right here and get instant results, which is really cool. You could even go to the composite, and you could make the composite that you saw a preview of earlier, which actually sees through the smoke, and then you can see what is happening on the ground. Then clicking the custom script, you could easily, if you wanted, for example, to make the shortwave infrared band 12 more prominent, you could simply increase it and instantly it will update. So I'm sure that you can see that compared to QGIS, this is so much faster, not even to have to think about QGIS crashing on you. All right, the last chapter, Sentinel Hub API. Question number 15. Very similar to the previous one. I've been downloading data and using QGIS to process it. What's the benefit of Sentinel Hub compared to standard methods? So if we just add on to what was said for the previous question, you do not have to here download tile by tile to process it and then stitch it together. You just select the bounding box, or you can just draw it or write in the coordinates, and then the mosaicing will be automatically done for you by Sentinel Hub. It is much faster. So also you have Sentinel Hub offers very powerful APIs with a very friendly user interface. So I can just show you this very quickly. If we jump to a request builder over here, you can select any one of the APIs, and then you just use user interface to select what you want and simply click send, and your file will be downloaded to your computer. It's just nothing simpler than that. Also, right to this topic, there is a blog that you can find on our Medium blog, why it's time to stop processing satellite imagery on your laptop. So it is written just for this question. Question number 16, how do I get Sentinel images into QGIS? So for this, we have a very specific webinar called OGC and QGIS integration, which goes step by step into integrating satellite imagery into QGIS. So be sure to check that out. In general, you will need a Sentinel Hub account and a configuration setup. And then it is the easiest way to just use a QGIS plugin to import those layers that you have set up to QGIS. Just follow the webinar and you will see how easy it is. It just takes a couple clicks. Question number 17. Are there any Jupyter notebooks for Sentinel Hub available? Yes. We have on our GitHub, we have example notebooks for our different APIs. And then also on our education page, you can see some notebooks that are use case related, such as for wildfires, for example, or for the volcano eruption. So if you go to GitHub, if you are in the Sentinel Hub GitHub, go to Sentinel Hub Pi, examples, you will find the API notebooks here. And also on the education page, if you just scroll a bit down, you will find these use cases where you can also find the interesting Jupyter notebooks, which actually do something useful. And then if you go to our Sentinel Hub website under develop and integrate and then Python, you will find all the documentation information on the Sentinel Hub Pi package about machine learning, EOLearn, our EOLearn package, and all the blogs. So feel free to check that out as well. And the last question, do all APIs have the same price? Actually, all the APIs except for batch processing are covered under all the packages, which includes the basic one. So then the pricing between the packages is not about which API you can use, but it is about how heavy your use is, how heavy use you need, how many requests, how many processing units. The exception is batch processing, for which you will actually need an enterprise account. If you don't know what batch processing is, this is an API that lets you download very large area images and also very long time range images. For example, as you can see here on this spinning globe, a whole world with Sentinel-2 data for a whole year processed and animated. Okay, this is it for the 18 questions. Let's jump to the live questions and answer sections.
Thank you, Munia, for explaining and answering all the questions we already received so far. I will first give word to Grega. He has some remarks.
Yeah, hi everyone. I just want to add some more words to what Monia mentioned. So first of all, on the highest resolution data, in Sentinel Hub, it's correct that we only support 50 centimeter imagery. The highest resolution currently available commercially is from Maxar Worldview, which actually is supported also in Sentinel Hub. But Worldview distributes data in several resolution layers and levels. And so far, we only integrated the 50 centimeter one simply because there was not that much of 30 centimeter available, because they're just one of the satellites, right, compared to all. That being said, with the Maxar Legion coming in soon, like the new constellation, we'll for sure expand this support to Worldview 30 centimeter as well. And if there is a demand by users, we definitely can do this already now. So, I mean, if somebody of you is interested, make sure that you let us know about it so that we prioritize this feature. That being said, you have to be aware that high resolution data is more expensive. So, like if you take 50 centimeter Worldview, it will be cheaper than 30 centimeter Worldview. There's also important thing to mention that Pleiades Neo is coming. So Pleiades Neo was launched a couple of months ago, and I think should become operational in the next few months. And as far as I know, Pleiades Neo also has 30 centimeter resolution. And as soon as it becomes operational, we'll work with Airbus to support that as well. Then a comment on the SLC, Sentinel-1 SLC data on support of that. So as Monia mentioned, we don't support it, and at the moment we don't plan to support it simply because the process of working with this data is so complicated that it's very difficult to do it in a like in a fast manner as people use Sentinel Hub for typically, right? You have this dynamic and interactive output. That being said, we have actually an option to generate coherence based on the SLC data in partnership with the Creodias. So this comes at an additional cost, and it's kind of a service where you say, I would like to have coherence over this specific area, and then we would simply trigger the processing of this data, and then once it becomes available, which typically takes, I mean, if you do it on demand, it will take probably 10 to 15 minutes. If you order like a large scale, I don't know, like a annual imagery of some area, it might take a couple of hours or even a couple of days. But as soon as it is processed, it then is available through Sentinel Hub as well as a coherence values. Yeah, that being that I just wanted to add. Sabina, back to you.
Thank you, Grega. So let's continue with our questions. So the first one is from Mikhail. He wants to know if we can tell him if there is any way to get a hologram from the Sentinel Hub of satellite images. I believe Anya can help us with that.
Hi, everyone. I'm not exactly sure what was meant by hologram, but if you are referring to an option to visualize data in 3D, then our Rio browser is offering a 3D view with which you can interactively navigate through the terrain covered by satellite imagery and then export an image of that. If you are referring to the option to reconstruct 3D models based on satellite imagery, for that you would need stereo pairs, and that is currently not yet possible with Sentinel Hub. Hopefully I covered the question.
Harold then is wondering if why are Landsat 7 images after the SLC failure not available in your browser?
So the short answer is we actually, we do support that. Basically, we do support all the Landsat data that are distributed by the USGS, and this also includes Landsat 7 data. What I imagine might be that you are looking into level 2, and I'm guessing, but I didn't check, that the Landsat 7 after failure is actually not included in level 2 because of the quality. But if you go to level 1 and do a search, I'm doing it in your browser, but as everything else in your, you can do this also in Sentinel Hub. So now you can see here the Landsat 7 from 1 week ago, and you will immediately recognize this issue with the failure. So here you have it. And while at it, I can also answer the question about the dynamic stretching. So this actually is, depends what kind of dynamic stretching is supported. But if you go, if I go back here, so this is the usual way. But then if you go to the effects, you can now do like some basic stretching of data based on the gamma and gain and so on. But you can even do the just the stretching of different colors. Now, if you're really adventurous and you would like to explore, you can click Advanced RGB Effects. And here you can then, for each of the bands. So here we are now stretching the red, green, and blue bands of the output, right? So this is not stretching based on the raw data, but here the data coming from Sentinel Hub, which are in this case visualized obviously with red, green, and blue. You can then simply dynamically modify this channel based on however you like, right? This is where it gets complicated, which is why it's hidden behind the advanced RGB effect scripts, but it actually can be done. And to add more to it, I mean, you can always go to custom scripts and do implement the stretching here however you like it. So I give back the word to Sabina.
The next question comes also from Harold, and he wants to know if we have any plan to implement more free access satellite images sources.
Yeah, so currently what we are looking at are mostly commercial data, satellite imagery that we will be adding, which is probably not what the question was about. For the free data that we are adding, we are mostly focusing on data available through Copernicus program. Again, not exactly satellite imagery, but derived products. And we are using Sentinel Hub, bring your own data functionality for this. So that's why the data that is available is not listed in the Sentinel Hub documentation directly, but in the Sentinel Hub public collections repository. And the link to there was in one of the first slides, I think from Sabina or maybe from Monia. So yeah, in short, we are focusing on the commercial satellite imagery and on the data available through Copernicus program. Not sure if that completely answers, but that's on our short-term plan.
And let me add in a bit more mid-term and long-term, we generally would like to have all the available data supported in Sentinel Hub. That being said, we are kind of limited to the data actually being available in a, let's say, efficient manner. The problem is that most of the data sources beyond Landsat and somehow Sentinel are either not available at all or are available behind a very clunky web interface where you have to download each individual image separately, which takes time and obviously is not fast enough for us to work with it. Or it has a license that it cannot be used, right, in such a use. So, I mean, we were exploring Spot, the old one, Spot 1 to 5 ones. And I mean, this checks both of the boxes that I mentioned. First of all, you can only download one individually. And I think you can only download 200 as a user. And if you want to, I mean, do something with that, you need to get a special license from, in this case, CNES, right? So the point is that it's quite complicated to work with this data. But if somebody knows about the data which is available on some cloud, we would definitely look into it and try to add it. I mean, probably not like in a short-term period in the next couple of months, but we for sure are looking into adding more data. It needs to be available in a cloud native manner. That's again an issue. Some of the data are simply so clunky that it's difficult to work with.
Maybe just if I can add, Grega, one more thing that we would also ask is if you already have a use case or would specifically like any of the data to be added, it's always welcome for us to hear such requests so that we can have some feeling of what data would actually be useful to have.
And to add some more to it, sorry, Anya, I mean, not sorry, but what would we really, really like is that that the people who have the data would come and they would share it as a bring your own data. I mean, they would ingest it in the Sentinel Hub using bring your own data functionality, which is now available and supports cloud optimized geotiffs and ZAR, and then share it with everyone simply by adding it to the collections.sentinelhub.com.
So let's continue with the next question. What are the differentiators between Playground and EO browser? Are they completely separate products? And is there a plan to slowly enhance Playground with more simplistic features?
That's a question that we ask ourselves often as well. We started Playground. This was the first application that we did when we launched Sentinel Hub. And we wanted to make it really, really simple for everyone to just explore the data without bothering too much about all the scientific complexities of the remote sensing. So we made it, I mean, we made it in a way that you have this mosaicing all the time and basically hiding complexity. But this hiding complexity also hides relevant information, such as when exactly some image was taken, whether all the images that are visualized are from the same date, and so on and so on. Which is why we then decided to create EO browser, like I know a year or two later, which we wanted to be like a correct representation of the data, focusing, I mean, let's say good enough that it can be used by scientists as well, but easy enough that it can be used by anyone. And when we had EO browser, we were adding more and more features there because, I mean, it was used a lot. And the playground, we always wanted to keep it simple, because we were and still are afraid that if we start adding features there, then again, people will get confused. The thing that amazes us is that there's still, even though we believe that EO browser is a like way better application than Playground, there's still more than, not more, but there are about the same number of people using Playground than EO browser. Like I think we get about 40,000 or 50,000 visitors a month using this tool. And I mean, we don't know why people are using Playground if there is EO browser. One thing that I can imagine is that they see, that they think that Playground is free and EO browser is not free, but that's not true, right? EO browser is free for non-commercial use in exactly the same way as the Playground is free. So, which gives, I mean, gives me an opportunity to ask whoever asked this question, why are you still using Playground and not going to the EO browser? But as a short term, I don't think that we will enhance Playground more, because yeah, we will just make it more complicated. We are focusing to improving EO browser, and what we would like to do is that if there are some things missing in EO browser that are so useful in Playground, please let us know, and then we'll try to add this in the EO browser, and maybe slowly phase out Playground altogether, because as mentioned, I mean, generally EO browser does everything and much more.
So Harold, then if you want to speak as well, I can unmute you. Otherwise, he's saying Playground displays the Sentinel-2 image out of the box. 0 clicks to see Sentinel-2 data, whereas EO browser you have to search first.
That's a very good point, Harold. I mean, that's actually the only thing that we see in Playground being better than EO browser, but that's due to simplicity. That being said, we are actually looking into how we can add this into EO browser in a way that it will be simple and fast, and maybe not 0 click, but 1 click, right? Yet still allow all the control that people expect from the EO browser. Sorry, from EO browser indeed. But it's a very good point. Thanks.
So let's go to the next question. It comes from Victor. He's asking, what is the Sentinel-1 precision in Z-axis? I guess this demands a little bit more complex answer. Marco, do you want to tackle this one?
Yeah, I can try. So basically, if the question here is really asking what is the precision of displacement you can get if you're doing interferometry, well, you can actually get millimeter precision. I mean, Sentinel-1 is a really good satellite. Of course, it should be noted that for this, you need the phase information, which is part of the SLC product. So in any case, this is not available on Sentinel Hub. So hopefully this answers it quite briefly.
Jan is wondering how can he test the Sentinel Hub services, as in, are there any trial accounts available? Anya, will you answer this one?
Yeah, this one is quite easy. We have trial accounts available. It's quite an easy procedure to register for one. Just go to our Sentinel Hub webpage where you can find a link for registration. And then with the trial account, you get all the capabilities of a normal Sentinel Hub account. So there is people often ask us if that trial accounts only have access to the low resolution imagery, which is not the case. So you get the full access. The only limitation comparing to the proper Sentinel Hub accounts is that you cannot use batch processing API and not third-party data import APIs. So yeah, once you have a trial account, you will get an email with links where we suggest you how to start with testing out the services.
Thank you, Anya. The next question comes also from Jan. He wonders if there will be any more custom script contests organized in the future and when.
So the answer is for sure there will be one. We are thinking about one right now, but I don't want yet to disclose what it will be about, so that it will be a surprise. We hope to launch it in the first quarter of 2022, so in about 3 to 4 months. That being said, if you or someone else has an idea for an interesting custom script contest that would add value to the world and to the remote sensing society, we would definitely appreciate it, so that then we can try to execute it. And while I'm speaking, maybe I can also answer the question from Nicole on what are the differences between Sentinel Hub and Google Earth Engine. That's a difficult and complex, the difficult question, which has a very complex answer, because there are many things that are different. Maybe the most important difference is the following. So Sentinel Hub is about API. That's maybe first thing to mention. Many people believe that Sentinel Hub and Neo browser is one and the same thing, but that's not really true, right? Neo browser is just a user interface using the Sentinel Hub APIs in the backend to do whatever you see in the Neo browser. But the core Sentinel Hub functionality are the APIs, which are then used by developers and remote sensing scientists and machine learning experts and so on to integrate in their own workflows to fetch the data to their workflows. And we really try to make this by design this service in a way that you integrate the APIs in your own environment, because we believe that most of the people building applications and workflows, they actually want to have the workflows running in their own environment, regardless of whether this is their laptop or their cloud infrastructure or the virtual machine on Amazon or wherever, but that it's their thing for various reasons, for privacy, security, IPR, and so on. And that's probably the main difference between Sentinel Hub and Google Earth Engine, because Google Earth Engine goes directly the opposite side. Their idea is that you try to do as much processing as possible directly in Google Earth Engine, using obviously the Google Cloud Platform in the backend, and then do expose the results in whatever way you want. Typically, just export them in the GOT for something like that. Or visualize them again back in the Google Earth Engine. So I'd say that the main difference is that Sentinel Hub is meant to power other the applications and processes running in other environments, whereas the Google Earth Engine is more kind of a platform where you can do everything. Due to that, it's probably a bit more limiting, because with Google Earth Engine, when you come to some point where you cannot do it any longer, you don't have any choice, right? Because Google Earth Engine is what it is. Whereas with Sentinel Hub, you can always then fetch the data at whatever point you get to with Sentinel Hub, and then process it further in your own environment, because this is how it's designed for. Yeah, that may be the main difference.
Thank you, Grega. So it seems we came to the end of today's session. Therefore, I would really like to thank you all for being with us today. I hope it was useful for all of you. And one more thing I would like to highlight, which was already mentioned, that if you don't have a Sentinel Hub account yet, you can create a 30-day trial account, as Anya explained. And if you are conducting, for example, a research, or you are in a pre-commercial exploitation phase, there is a possibility, the opportunity offered by Network of Resources program, which provides ESA-sponsored accounts and also free access to high-resolution commercial data. For this, you need to visit the link stated on the slide for more information about this sponsorship. So stay tuned, updated, follow us on social media for our future webinars, and I hope to see you the next time. Thank you very much.